Carbon is a small atom. There are 4 electrons in the outside orbital, and for our purposes here, the 4 are equivalent. They're all the same for our purposes here. A carbon atom makes a tetrahedron. It's a triangle sort of thing. Sometimes you see a 4-sided die. That's a tetrahedron. The simplest organic compound has 4 hydrogen atoms on each of the 4 corners. It's called methane. Let's start here. Methane is a gas. When I was a student, I would say, well, what's the big deal? This is stupid. Okay, it might be stupid, but methane is natural gas, and it cooks our food and keeps our house warm. The molecule is important. Carbon attaches to each of 4 hydrogen atoms, but importantly, it attaches to itself. 2 carbon atoms attached together and then covered with hydrogens is called ethane. Propane is 3 carbons, and butane is 4 carbons, and pentane is 5 carbons. Notice that every carbon has 4 handles with 4 things attached, and importantly, the bonds all rotate. Natural gas is a mixture of stuff, but it is mostly methane. But it has lots of other molecules in trace amounts. As the molecules get bigger, the boiling point goes up. Methane is a gas. If you wanted to find liquid methane, you'd have to go to Jupiter. This table shows the boiling point of small alkanes. If you want to put a flammable gas in a tank, like for barbecues, propane is best. Methane could be put in a tank, but it would have to be a very strong tank or kept very cold. In many parts of the country, houses included propane tank to hold the propane for heating and cooling. The propane companies that fill these tanks sell it by the gallon. They sell it as a liquid. Notice the boiling point of butane. This is 0 degrees centigrade or 32 degrees Fahrenheit. This is about the temperature of your freezer. If you want to put a flammable gas in a little plastic bottle, use butane. It wants to be a liquid anyway. The boiling point of pentane is 36 degrees centigrade. Body temperature is 37 degrees about. So if butane is a wannabe liquid, pentane is a wannabe gas. Pentane is a common solvent in laboratories. Let's use this image. If you had a beaker of pentane and poured it on the floor, the liquid is so volatile that it would almost never reach the floor. If you did this and got down on the floor, you definitely would not find any pentane. It would all have evaporated. And then if you decided to light a match, that would be a really bad idea. Let's jump into the area of stereochemistry. Let's put something different on the methane. It makes no difference where they are the same. How about for ethane? Same. There are 6 positions, but they're all the same. How about propane? We have the ends. These bonds all rotate. There are 6 places, but the 6 are all the same. And the middle is different. There are 2, but they are both the same. So there are 2 possibilities, in the middle and on the end. Butane is the same. The ends are the same. The middle is now 4 locations, but the 4 are the same. This field quickly becomes complicated, but it is not important, certainly not important to us here. The something different we want to use is the OH group. The OH group? Think water. The structure of water could be HOH or H plus and OH minus instead of H2O. If we add an OH group to methane, the physical characteristics are much different. The oxygen is bigger than the carbon and it dominates the behavior. The methane almost turns into a water sort of thing instead of a carbon thing. This is a liquid. It's called methanol or methyl alcohol, or historically it might be called wood alcohol. This material goes back to the earliest times in human history. It is produced by bacteria and sometimes used as a fuel, even today. If we put an OH group on ethane, it becomes ethanol. Ethanol also goes back to the very early history of humanity. Ethanol is produced by microorganisms, especially yeast. This is the alcohol that is found in fermented beverages like beer, wine, and whiskey. Ethanol is also used as a fuel. It is added to gasoline. When there are references to oxygenated fuel, this usually refers to ethanol. A recent change in our society is the use of corn for the production of ethanol. The corn is grown and the starch is digested to sugar. The sugar is fermented to ethanol to be added to gasoline. Ethanol and methanol can only be formed in one way. Let's take a look at propanol. If we add the OH group, it can attach in two different ways, on the end or in the middle. The middle position has a new name, isopropanol. On the end is just propanol, or you might hear N-propanol. And notice that if it is on the end, the 6 positions are the same, and if it is in the middle, the 2 possibilities are the same. Before leaving this, I want to take another look at stereochemistry. When the number of carbons goes over 3, there are different possible orientations. They're called isomers. Butane has 2 possibilities. Is there any other way to put it together? I don't think so. How about 5? Actually, there are only 3. If the one on the end is put in the middle, it still only forms in one way. If both end carbons are moved in, it forms a pretty cool tetrahedral molecule. I just looked it up on Google. The trivial name, or like the slang, is neopentane. Perhaps one of the most common solvents is hexane. How many possibilities? There are 5. Heptane, 7 carbons, has 9 possibilities. Octane, with 8 carbons, has 18 isomers. The isomers get more numerous in an exponential scale. Classes in organic chemistry fuss about this, the nomenclature, and the specifics of the structures, of course, but we're not concerned about that here.